Okay, there's a bit on scientific notation. And scientific notation has to have one digit in front of the decimal. And I don't believe there's a rule for how many digits follow. Kind of depends on the number. Times 10 to some exponent. And if you're moving in part A, we're moving our decimal right. So we're going to make a little tiny number look a lot bigger. So I have to move it right 6 places in order to get one digit to the left of my decimal point. So this can be rewritten as 3.2 times 10 to the negative 6. Same idea with a big number. I'm going to move it out. I'm going to move this decimal. It looks like 1, 2, 3, 4, 5, 6 places over. So I get 5.3412 times 10 to the positive 6. And on to the next. Okay, rationalize the denominator. Mathematicians don't like radicals in the denominator. A reminder. So we're going to multiply by the version of 1 on this first problem that will get rid of the radical in the denominator. So we get 2 square root of 3 divided by 3. Now, when I tried entering these numbers in XYZ homework, I had to do this. It didn't recognize it until I typed it in this way. And we're typing it in as a line, but then we get to take a look at it. And the weird thing was it showed me correctly in the notation, but for whatever reason the software didn't like it. So it's 2, and they use SQRT for that square root symbol. You have to put the number in the square root in parentheses. That's where I was having trouble. So those are parentheses around my numerator, and there's my denominator. Okay, on to B. So we have some addition subtraction in the denominator, which means in order to rationalize it, we've got to use the conjugate. Now, the conjugate of any binomial is going to be the same numbers with the opposite sign. So the conjugate here is going to be 1 minus square root of 5 over 1 minus square root of 5. And I'm going to put parentheses around the numerator because I've got to remember that I'm going to multiply both of those by 3. Actually, some parentheses around both numerator and denominator will help. All right, I'm going to painfully do all 4 multiplications in the denominator. They'll simplify, you'll see the pattern, and then you don't have to write all this stuff out. So I'm doing 1 times 1, which is 1, 1 times negative square root of 5, which is negative square root of 5. Now I'm going to my second multiplication, square root of 5 times 1, and then square root of 5 times negative square root of 5, which is a negative 5. So what happens is, and this is the point in the conjugate, is those radicals will always cancel each other out, and you're left with just a number in the denominator. In the numerator, I would have 3 times 1, which is 3 minus 3 square root of 5. And so that's going to be 3 minus 3 square root of 5 all over 1 minus 5, negative 4. Again, interesting to write that into the homework app. All right. I better identify my answers. Okay. On to some simplifying. Okay. Square root of 49, x to the 6, y to the 8. What I'm going to do is I'm going to take this implied root here of 2, and I'm going to turn it into a fractional exponent. I am going to keep the number as the square root of 49 because I know I can, when I have to come up with a number, I usually leave it as a radical. Times x to the 6 divided by 2. So I took away the square root symbol and put in division by 2. Same with the 8. And this simplifies to 7, x to the 3rd, y to the 4th. All right, little multiplication. And again, there's 4 multiplications here. Square root of x times square root of x is just x. So I'm multiplying here and here. So next multiplication, negative 5, square root of x. Okay, the second two multiplications, -4 square root of x plus 20. So we get x, -9 square root of x plus 20. Kind of hard to believe, but that's actually a quadratic. It's just degree 1. All right, last couple of examples in the notes. Cube root of 64 divided by 125. So with any root over a fraction, I can split that up into both numerator and denominator. And I want to do this because I can see that these are both perfect cubes. If you're not sure, just put it in your calculator. So what does this give me? Cube root of 64 is 4. Cube root of 125 is 5. And we are done. Okay, next problem is square root of 27 times the square root of 12. Just a quick reminder. We're going to multiply these. What's 27 times 12? Okay, 324. Now we see if we can reduce it. Okay. I know 4 will divide into that because there's a 12. So 324 divided by 4. Okay, that's 81. And 4 won't go into that again, but 81 is a perfect square. All right. So this is square root of 4 times square root of 81, which is 2 times 9, 18. And that is it for this video. I will see you in class.